Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Hi, we're at Castle, home of the night.
And we're here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Susie, and you can call us here in Bakersfield at 636-4357. In San Luis Obispo and surrounding areas, you can call 1-866-636-6284. You can email us at dothemath@kern.org. You can watch online at dothemathonline.net. And we are also on social media, Facebook, Instagram, Twitter, and YouTube.
All right, a lot of different things on social media. Want to send out a big thanks to a lot of the parents and relatives that have liked the Do the Math Facebook page, because every time they see a relative or something, then they like the page. And that's always good, because then they can let other students know about Do the Math. Anyway, we do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. And we are down to our final month. So at this point next month, we have 4 more weeks to go, and then that will be the end of live programming for this year. So if you do need some help on your math before the finals come up at the end of the year, refreshing, possibly reviewing something from the beginning of the season, simply give us a call. We always have tutors available, but 1 more month. We'll be going back out to Castle to check out the STEAM Academy. We have a very special guest in studio. We'll meet that young lady in a few moments. But first, let's take a look at today's Math in the News. All right, today's Math in the News has to do with the moon. Have you heard the saying, once in a blue moon?
Yes.
All right. And have you ever seen a blue moon?
Not really.
So what are some different moons that you're familiar with?
Well, I've seen the blood moon a while back, and
Okay.
I've watched a few of the
Eclipse?
eclipses, but I'm not a big knowledgeable on the moon.
All right. Well, you know what? There is something going on actually right now. So we'll take a look first of all, because the blood moon you mentioned, that happened a little while ago. A couple weeks, a few months ago or whatever, there was a blood moon.
Not too long ago.
Right. And what's going on right now is there is a supermoon. And I believe tonight, if you're able to see it, and then tomorrow morning will be the only times left to see the optimal supermoon. So the supermoon is considered to be, well, the moon is a supermoon, when a full moon is at its closest point to Earth on its elliptical orbit. So you can see here how everything has to line up in order for a supermoon to occur. Now, what's the big deal about a supermoon? Well, if you had noticed the last few nights, it's a bit brighter and a bit larger than normal.
Definitely, yeah.
So the supermoon you can see is 16% bigger and it's 30% brighter. Because when the moon is at its furthest point away from Earth, it's actually about 30,000 miles closer at that point.
That's a
when
big
it's
difference.
a supermoon. So you can see, I mean, if you go out tonight and if the clouds aren't obscuring it too much, I mean, because last night I could really notice it, and you might be able to tonight, it just really lights everything up at night.
Definitely last night I didn't need to turn any lights on when I went outside or
Yeah,
anything.
so that's the supermoon
Yeah.
helping you right there, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon. In studio with us, we have Katelyn. How are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Old River Elementary and I am in 4th grade.
How's 4th grade?
Good.
What's so good about it? You have to go to school longer now, don't you?
Yeah.
An extra 30 minutes every day? What do you like about 4th grade?
I especially like science and social studies.
Oh, good. Now, do you have an opportunity to do a lot of science and social studies in your regular classroom? Because I know that a lot of classrooms are focused on reading and mathematics and stuff like that. So do you get an opportunity to do a lot of math and social
Yeah.
studies, or science, I mean? Can you tell us about one of the things you've done in science?
In science, we have been learning about rocks and minerals.
Oh, good. So that's a big thing because you're doing the geology, right? And I think that is something that you're also doing in another program that you're in also, right?
Yeah.
Working on that a little bit? Okay, good. So everything's going well with 4th grade?
Yeah.
How's the math?
Good.
Pretty good. All right. You know what? We're going to work you over a little bit today, young lady. As a matter of fact, why don't we do a quick problem right now, all right? Head on over to the board. And you said that you were pretty comfortable with fractions right now, right?
Yes.
Okay, so why don't we go ahead and, you know what, draw a fraction line up there. And you select the, okay, yeah, you might just have to take your hand a little bit away from the board so you don't,
Yeah,
there you go.
further down there, yeah.
So you can choose the number on top, the numerator, any number you want. All right, and I will make the bottom one a 5. Now you're going to add another fraction to that.
Okay.
So go ahead and put your addition sign next to it. And once again, you may select the numerator, the number on top. All right, and I will, let's just make it 5 again. So we were going to do that, right? So let's just go this way. And Katelyn, explain to us how you would solve that problem. And if you need some help, Susie's right there.
Okay. You would solve 2/5 plus 3/5 by adding the two numerators on the top, and 2 plus 3 equals 5. And that would equal 5/5, which would also equal 1 whole.
Oh, good. I was wondering if you were going to be able to see that right there. So it does equal 1. Now, you added the numbers on top to get 5. Why don't you add the numbers on the bottom?
Because the numerators have to be the same to add, and you don't add numerators when you're adding fractions.
Well,
I
good.
mean denominators.
Well,
not numerators.
perfectly explained right there. So nicely done on that. So we'll give you a break right now. As I mentioned, we were going to go out to Castle to check out the STEAM Academy. But before we go out there, let's take a look at what goes on at the Castle STEAM Academy.
So right there, I'm going around.
But we also want some alleyway where the dolls can go.
At Castle, we're wanting to transform learning and have things look differently here. So one of our major goals is to have integrated learning with STEAM in the core.
You said this was about 9 inches? Where's your measuring tape? Show me.
The students are the center of the learning. The learning is not dependent on the adult who's facilitating the instruction anymore. They're a guide, and the students are taking charge of their learning, and they're immersed in something that's hands-on and that's very interesting to them.
So get it colored, tape it together, then come see me and get a magnetic wand, okay?
We are a STEAM Academy, so what that means is we have a focus on science and math. We have labs that our students visit weekly.
It doesn't have to be curved. You can make it curved, but it doesn't have to be curved.
And while our students are in those labs where they're learning hands-on, our teachers are pulled away and have professional development with their teams where they're able to plan and look at data to make sure that their core instruction is strong.
Listen carefully. Listen beyond the cars. What else do you hear?
Teachers have planning time with the specialists. Our general ed teachers will bring in a focus standard that they're working on, and then the specialist will help the teacher come up with a way to teach their core content through the specialty.
Keep the head nice and round. You might have to go back to the beak if you pushed on it and make it pointy again.
We're taking education to the next level. It's fun to be at a school where you know you're changing the face of education and what you're doing for your children on a day-to-day basis.
Trees, grass, cars, houses, roads.
We're taking a new approach, especially with PE. So 0. Okay. So hold it right up there. It's been a different way of thinking for our school, but it's blossoming into something amazing. tracking their steps during that time, tracking their heart rate during that time. That's kind of where the PE comes into it. But for the science part, trying to use our senses to notice things they don't ever notice before.
They leave me again.
Today they've been hired as mechanical engineers for a toy company to make a magnetic race car track. Build that track, elevate it up, and be able to use a push or a pull force with a magnet around the track in 30 seconds or less.
But you need like a round edges.
And do you think that having a simple track will allow you to get around that track faster because you have 30 seconds on the time constraint? So we're getting the science in with magnetism, the math, they are working with time.
These types of laboratories haven't existed before because we're preparing the kids for their future that doesn't exist, for jobs that are just now starting to percolate and surface, and we're trying to give them the skills they need so that they can adapt to that dynamic work environment.
A program like this is obviously very expensive. We are fortunate to do it because of the school improvement grant. It's money from the federal government that's allocated to the states, and then you apply to your state government. And luckily, we were awarded that grant of over $7 million. We also partner with Chevron. Chevron has been a great asset to Castle and a great partner.
This can be a best practice for the entire state, leveraging partners, getting parents involved, getting corporate sponsors involved.
We were interviewing different students about their perceptions for the first month of school, and one of them kind of stands out. She just said, "I just love it here at Castle." And I said, "Well, why? Why do you love it so much?" And she's like, "This school has just changed. It's just better." And it just meant a lot to hear that from a child and see that they could tell something was different and it meant a lot to them. They were happy and they wanted to be here.
All right, well, we saw a little bit about what's going on with the STEAM Academy over at Cuyama Elementary. Right now, we have an opportunity to go live, check out with some of the students and Tony at Castle.
Thanks, Mike. So I think you and our audience members got to see a little bit about what we do here at Castle in that great promotional video that some of the KETN crew made for us. And we'll show you here where all of that great learning takes place. So this is our art lab, and you saw in the video that we have a grant from the state that provided us with these great labs in addition to a partnership with Chevron. And here in this art lab, you see that it's just a beautiful environment. Kids are doing work not just surrounding art, but the way that art integrates into the other core subjects. So some of the work that you see on the wall is with relation to proportion and scale. It's linked to history and ancient Greece. And kids are learning about all of that in these labs and how it connects back to grade level content. This is actually one of my favorite places to come and watch students work. It's what we call our Zen Place. And here is our technology lab. Kids in the tech lab are doing some neat work with, you see a green screen in the corner. They make public service announcements that have to do with projects in their class related to recycling and the environment. They work with robotics. They learn about computers and coding. And they also get to tie that back into core content with the use of computers, Chromebooks, and Google tools. So what we'll see today in the engineering lab are students working on an engineering challenge, and we find that this is where we get a lot of mileage out of a very simple challenge, and the challenge that we chose today is perfect for even students just to do at home. So this is a balloon rocket challenge. And you'll see that we've got some great Castle Knights here ready to take on the challenge. And they are eager to get started. And to give you a little bit of an introduction about what they're doing, I'll hand it over to our other illustrious academic coach, Bree Gage.
Hi. Okay, so today we are going to do a balloon rocket challenge. And it's a simple challenge that you can do with all kinds of things at your house. Okay, so we have 3 choices here. You either are going to make your balloon rocket the slowest, the fastest, or you want your balloon rocket to go the furthest. Are you ready?
Yeah!
Go!
So we can blow up the balloon and then blow up the little balloons and then tape it to the side.
Yeah, because we should put like tape on the side.
That strategy, and if that strategy doesn't work, we could try another one.
We could add these to the sides to boost it on the end. We could get straws to, so like, we could put the, like, here's one balloon, here's the other, and another balloon over there. We could put it on the string and you tape it right here. So let's say that this balloon's blown up, okay? And it's taped onto the string. You put tape right here, and there's air.
And then,
So why are you going to use the little balloons?
so it could get more.
They're like boosters.
Yes.
So are you trying to make we're looking for the
Farthest, yeah.
furthest,
So it could
okay.
like add extra air into it.
And we could, okay,
So what else could you do?
we could blow up all three balloons. We could blow up all three balloons.
Or we could do
We could
two
tape
balloons and
them
connect
all
them
together. Act these like balloons,
the
and
sides.
these are like boosters too.
Okay.
So 3 balloons and 3 balloons right there. So we tape all that together. They could act like they're all boosters. Yeah, that's what I did.
Tell me about your thinking.
Alright, so what we're doing is that we're doing the fastest. And what we're gonna do is that when this balloon is blowed up, and when it's on the string, we're gonna get the tape. We're gonna put it around the balloon right here. And then we'll put a paper clip right here. So that's why when you say go, we'll let go. We'll take off the paper clip, and then what we hope is that the balloon, that the tape will squeeze the air, and the air will come flying out.
Okay, and are you going to use a small balloon or a large balloon?
A small one.
Okay, and you're going for fastest?
Fastest.
All right, I want you to think about that. Talk about which size balloon might you use and why.
I think big.
Why? Why?
I said big one because it could contain more air.
And what's that going to do?
It's gonna make it go longer, but it is gonna go faster.
Something to talk about, something to think through.
So it looks like students are well on their way. We'll check back soon and look at their progress. Back to you, Mike.
All right, thanks for that, Tony. We'll check in on students from Castle STEAM Academy in a little bit. We do have phone tutors available until 5:30 this afternoon. We have Katelyn in studio, and since you're here, you might as well get back to work. You ready? All right, head back over. All right, Katelyn, you come up with the first fraction altogether, numerator and denominator.
Okay.
5/12. Excellent. To that, we will add,
Okay.
let's say, 7/6. So now, if you would be so kind as to explain what to do, and if you're stuck, you've got Susie right there.
Okay. So this is an improper fraction because the numerator is larger than the denominator. So you would want to change that to a mixed number. Is that right?
Do you want to do that now or wait till the end of the problem?
We could wait till the end.
Yeah, that would be a good thing to do.
Okay. So then we just add these two?
Well, first look at your denominators. So you need to have them
Common
be...
denominators?
Yes, that's right.
Well, this is mental math because 6 goes into, because half of 12 is 6. So that would be, this would also be a 12. So then that would be a 12. And then we'd have to find, and then this would be over here to a 7.
Okay, so let me show you something. Have you multiplied by, have you done something like this yet? Where you multiply by a special kind of 1?
I don't think so.
Okay, because you do get 12 on the bottom, but however you got from 6 to 12, you need to do that here. So from 6 to 12, you multiply by 2.
Oh,
So, yeah.
so this would become 14.
Yes. So now your new problem is 5/12 plus 14/12. So and like remember how you said before you only only add the numerators? You do that after you get the same denominator.
Okay.
Okay?
So then now you'd add these two.
That's perfectly right.
5 plus 14 would equal 19 twelfths.
Okay, and now you can do what you were talking about, turning it back into a mixed number.
Okay. So we haven't done this in a while, so I kind of forgot this. So can you kind of walk me through it?
Yep. Basically, I can give you a shortcut, but 19/12 is 12/12 plus how many other 12s?
Plus 7.
Right. And this is 1. So 19/12 is 1 and 7/12. Now, a lot of people just do it like this. 19 divided by 12. How many 12s are in there? 1. 1 times 12 is 12. There's 7 parts left over,
So
and
that'll
those
be
parts are
1 and 7/12.
right. Yes.
Okay.
So this is kind of the quick and easy way. Hopefully this makes sense to you.
That's how we
19/12
usually do it, the dividing.
Okay. So then, yeah, so we got that 1 and 7/12 then.
Okay.
Well, good. So now we've got your feet wet with that. So go ahead and erase the board. And Katelyn, come up with another fraction.
Okay.
And to that we will add, let's go 6/5. 6 over 5.
And then we'll change this to a mixed number first. You know what? I'll do that at the end, actually. And
Okay. That will be easier.
then you find a common denominator for these two, and that would be a 10 also, because that would be multiplied by 2, and that's also mental math. And then for this, you do 6 multiplied by 2, which would equal 12. So that would be 12/10. And then to change it into a mixed number.
Well, we don't have the answer yet.
Oh yeah, we add.
Yeah, you have to do the 7/10 plus the 12/10. Okay? So you need to be careful about the equal sign.
Okay.
Okay? All right.
And 7/10 plus 12/10 equals 19/10.
That's correct.
And now do you change it to a... Okay. Then that would be 19 divided by 10. And then 10 goes into 19 once. And then 1 times 10 is 10. Subtract, and that would be 9. So it would be 1 and 9/10.
That's correct. 1 and 9/10 is very correct, yes. And you write really well.
There you go. Nicely done. Great work on that. The first time working with fractions like that. Well done. And because you did so well with that, we're going to give you a gift card courtesy of our friends at Chick-fil-A. 636-4357 is the phone number. We do have phone tutors available until 5:30. We'll be back with more right after this. Today we're at Cuyama Elementary School, home of the Bears, and we're here to... Well, we're back at Cuyama Elementary School. We've got some 4th and 5th grade students working on pattern blocks, talking about their attributes, the different sides, angles, and what makes them different than some of the other blocks, even though they may have some of the same qualities, right? Because as we found out, this has 4 sides, and that has 4 sides, but are they the same?
No.
No, right? Because of the angles in them, right? We can tell that one is a square, one isn't. So quickly, let's talk about the difference between some of the angles, right? A right angle has how many degrees? 90 degrees, right? So on a square, all of the angles are right angles, they're 90 degrees. If I have an angle that is a little bit smaller than 90 degrees, 89 all the way down to 1 degree, right? What kind of an angle is that? You guys remember? Acute or obtuse?
Acute.
Acute, right? Just think about it. It's small, it's cute, right? Okay, that's how some kids remember it, okay? So an acute is going to be smaller than 90 degrees, okay? So if we take a look at, whoop, the top of this, right? That's less than 90 degrees, isn't it? So that would be an acute angle on here, okay? If it's larger than 90 degrees, what kind of an angle is that going to be? Obtuse, right? So it's going to be larger than 90 degrees, and we can see that this angle here is going to be larger than 90 degrees, okay? So now what I would like you guys to do, and you can take as many blocks as you want, whatever types you want, I want you to create some sort of a design for me, okay? So make any type of design you want with all of the blocks, whatever blocks you want to use, okay? When you are through though, what you need to do is you need to be able to identify some of the shapes in it and be able to classify them as far as sides and angles. Are you guys ready to go? All right, get to work. What have you got going on over here?
Trying to make a house.
So you're trying to make a house? Okay, and what have you started off with?
Squares.
Okay. And so what is the measure? So you've got a 3 by 3, right? Okay. And then what is the one piece on there that makes it look like a house more?
The triangle.
The triangle, right? Okay. And do you know what type of triangle that is? If all 3 sides are the same? I'll give you an option. Equilateral, where all sides are the same, or isosceles, where only 2 are the same. So which one do you think that is? 2?
The first one.
The first one, right? Equilateral, right? Because they're all the same. What have you got going on?
I'm trying to make a double flower.
A double flower. There you go. What kinds of things have you got in the double flower? What shapes are you using?
I've got a long diamond,
Okay.
a square, and a triangle.
And anything else? What's the yellow thing in the middle?
Pentagons.
How many sides are on that?
6.
6. So that would be a hexagon, right? Think about 6 and hex. They both have X's. Pentagon has 5 sides. Nicely done. Let's head on over to this table for just a moment. Oh, here we go. We're going upwards, right? What have you got? Don't know yet? What kind of shapes are you using?
Squares, hexagons, and diamonds.
Okay.
And pentagon. And trapezoids.
There you go. Nice use of the vocabulary. Yours is also gaining some height. What have you got?
I have triangles, diamonds, rectangles, squares, and I forgot this one.
Trapezoids.
Trapezoid. There you go.
And can you quickly just show us how you made some of the smaller triangles into other shapes? Do you remember when you were doing that?
Yes. I made this one the trapezoid.
So show us again real quick how you can put it on top of it maybe. Yeah, so you can just put it right on top of that, the way they fit. There you go. So you can see how one shape, if you duplicate it, can create into another one, right? All right, there you go. Nicely done. Kids working with pattern blocks, working about the sides and the angles, all at Cuyama Elementary School. And once again, a big thanks to the staff and students at Cuyama Elementary. Always a lot of fun when we get to go out to different schools and work with the students. We have Katelyn, you're getting quite comfortable with the fractions now, right?
Yes.
Well, get over there. Let's keep on going then. So, I will give you a fraction now.
Okay.
All right. Let's go 8 over 10. We'll start simple. And I would like you to turn that into a decimal. So I need 8/10 written as a decimal. Now, how did you know to do that?
Because because when turning a fraction into a decimal, and if it's a 10, you'd always put it right here in this place. And if it was a hundredth, if there was another 0 there, you'd put the 8 in this place.
Okay, so let's do that. Over on the left-hand side, so move over to the left. Let's make it 8/100ths now. So 8 over 100. And show me how that would be different. Perfectly done. Now, so we've gone from a fraction to a decimal. Turn that into a percent, the 8/10. All right, so we can get rid of the other part over there.
Okay.
So now we'll go 8/10.
I'm going to give you a hint, okay, with a different number. Okay, so 42% means 42 out of 100. So percent actually means hundredths.
So this one would be 8%?
That's right. That's right.
There you go. Easy enough. 8%.
Very good.
All right. Now, let's move on to another step of this. All right. So go ahead. Get rid of all that stuff on the board. All right. Let's go with 8 over 25. Now, what I'd like you to do first is turn that into a percent.
Okay.
So remember, percent is out of 100. So you need to get something over 100 first. And if you're stuck, you've got Susie right there.
So let's put the 100 over here, okay?
Okay.
And think, how did you get from 25 to 100?
You multiply by 4.
Good. Now you always have to do the same thing to both the numerator and the denominator. Very good. So then what's the percent?
32%.
Okay, and now I need you to put that in decimal form.
Oh, okay, yeah, go ahead.
All right, so you're feeling pretty good? So you see how you can go from 25 to 100, right?
Yes.
All right, erase the board. Let's now go with 17 over 20. So 17 over 20, turn that first of all into a percent, and then put it in decimal form.
Very good.
And then as a decimal, 0.
There you go, nicely done. You've gotten a hold of this really quick, right? All right, so go ahead, get rid of the board. And I will let you come up with the next fraction.
Okay.
Oh, there you go. All right, so now turn that into a percent and then a decimal.
Okay.
There you go, nicely done. So you're getting a little bit of 5th grade work out of the way right now today. So nicely done on that, Katelyn. Hey, we do have phone tutors available until 5:30. Don't forget, if you're in San Luis Obispo County or elsewhere other than Kern County, that phone number's at the bottom of your screen periodically throughout the program. Right now, we do have another opportunity to head out live to Castle Elementary. Check in with Tony.
Thanks, Mike. So we're back. We've got some groups ready to test. The really neat thing about this challenge is while students are working on that, they're making decisions about what works, what doesn't. Testing, again, going through the brainstorming process, but then also figuring out how do we use mathematics and science to really make our design better and to test which one is, according to our challenges, the best. And after a couple challenges, we might even throw them a curveball and say, hey, we would take 2 of your big balloons for a long, slim balloon. Would you like to do that? So we'll see what they say to that, but for right now, we've got some groups ready to test.
All right, you ready to go? 3, 2, 1, go.
Okay, go.
Uh-oh, tape it?
I think they taped it.
Alright, go back to your tables and figure out what you did. Okay, here we go. Ready? Here we go.
No.
Okay, here we go. Hold it. And 3, 2, 1, blast off. Okay, let's figure it out. Go back to your tables. How can you make it better? How can you make it better?
Screw over tables so that way they can. It's heavy.
So make sure you hold it up and hold it tight. And who or do you have to let it fly?
Yeah, we need 5 people.
We need Angel.
Angel, 5 people. We need.
Here, Cindy, you hold it. Okay. Hold it.
Okay, ready? Grab it. Grab one. Come here. Get in here. Okay, so put 2 hands on your mark. Get set. Everybody. Release. And hold on. Most successful, right? Okay, go back to your tables. Figure out why that didn't work. Go. Talk it out. What happened? What went well? What did not go well?
It wasn't tight. It was just, I know what happened. Wait. Alright. Someone, I think it was Robert. Fin, like rocket fin. Oh, whatever fin worked.
About what you think worked well and what you might want to change. So what worked really well?
I think it was like stick together, and that's why I didn't like.
Okay, so things stuck together.
It went far kind of a little.
Okay. Oh, I'm sorry.
It went kind of far now a little bit.
Yeah.
Okay. So how did I know that you were all pretty excited about multiple rocket boosters? How did that work out? Did that work out to your advantage for this one? No?
It kind of felt good saying like at least one of them got like most of it far, even though it's only one balloon that was pushing it.
Okay. Now I noticed
And
that
it was like very heavy.
Right. You staged them all using the clips. How was that getting them to take off?
I feel like
because
the
it was
clips,
holding the air inside, and as soon as we unclipped the clip, it let the air out, so it started moving.
Okay.
and like since the clips were like, and we like twisted them, it was like kind of stuck.
Stuck.
On
Okay.
like a sticky part in the like in the middle of this, or at least this right here.
So then I'll ask you if you want, you can trade in all your balloons
Yes.
for.
Yes.
You sure?
Yes.
Okay, because it's final. That's it? All right, that's your only booster. You good?
Yes.
Okay, you can reuse some of that tape.
Then the tape ended up crumbling up once the balloon was flat. So once the balloon's flat, the tape crumbles up because I have nothing else to decapitate on.
Okay. And did that affect the
Well,
movement across the street?
Well, to me, it didn't because if we added fins, so that's what it knows which way to go, or like make it to where this has to face a certain direction. We're gonna do that now with more tape.
Is that what you're gonna do this time? Okay. All right. Well, Dr. A has something over here if you're interested. Did you have them switch it out?
They chose.
So you can choose to keep the balloon you have, or you can go for this balloon that we make.
Can we try it?
Yes, you may.
It's really hard to blow on there, though.
Do you guys want a different balloon?
Wait, are we using the same balloon?
Told you, Jimmy.
Anything different?
More farther.
Why?
Because it's longer and it can hold more.
Okay, tell me more. Keep going. Keep thinking about that.
Okay, I can't.
The little tiny balloon, what do you think that would have done?
Like not go for it because it can't hold. Like the little tiny balloon, like kind of ruined it because it did.
Okay, so what about the large balloon that we just used?
That one, like, we were having trouble with it because the little mouthpiece right here, that was the foundation of blowing it across the string. When we tried to get it off,
So your thruster was blocked.
we clipped it too hard, so it was like this.
Okay, and
So when we unclipped it, it took a while for it to, like, it was like this.
why do you think this is going to go faster than that?
We don't really have.
Talk about it. Talk about it. I know, that's okay. Think about it.
All right, so reflections and redesign stage is well underway, and we'll be back soon with some final tests. Back to you, Mike.
All right, thanks for that, Tony. Nice to see the first attempts at those balloon rockets and what happened. And now, obviously, they have to modify those a little bit and see if they can improve upon that first design. All right, Katelyn, you ready?
Yes.
You had enough of a rest?
Yes.
All right, back over to the board. And start over on your left-hand side and choose any number you like. And I will say add 4. So put +4. And now you can add or subtract any number you like. -3, and then I will go -5. And now, Katelyn, add or subtract any number you like. +7, and now I will add. So we'll put plus, and then how old are you?
9.
Add 9. You select the next one. -8. Let's go +4. Pick another one. -11. And what year were you born in?
2009.
So we'll go -9. I won't put 2009 up there for you. All right, so I want you to evaluate that. I want you to tell me what all of that comes out to be.
Okay.
Now, can you do that in your head?
I don't. Maybe.
Maybe? All right. If you try to do it in your head, explain to us as you're doing it how you're getting the next number.
Okay.
All right? And then if you need some help, we've got a couple of different things we can help you out with, all right?
Okay. So if I were to do this in my head, I would easily know that 2 + 4 = 6, and 6 - 3 is 3, -5 be -2,
Right.
+7 would be, is it 9?
Yeah, if your -2 is like to the left 2, and then 7 would be to the right. So it would take you 2 spaces to get to 0, and then you would still have 5 more.
So, Susie, how about you put a number line up there? Because you're on the right track, but now that we've got some negative numbers in there, it makes it a little bit more difficult.
Hope I made it big enough. So let me do it like this.
Can you write sideways, Katelyn? That's pretty good. Yeah, you write sideways.
Those negatives just take up more room. Okay, so you did 2 plus 4 is 6,
Yes.
and then minus 3
is
3, and then minus 5, and you got yourself to negative 2, right? And then we want to add 7. So look, 1, 2, 3, 4, 5, 6, 7.
So that'd be 5.
Okay. And then plus, go
5
ahead.
plus 9. 5 plus 9 would be 14.
Okay, I'm going to help you keep track.
Minus 8 would be 6.
Mm-hmm.
Plus 4 would be 10.
Mm-hmm.
Minus 11 would be negative 1.
You learn fast. Okay.
And then minus 9 would be...
So I'll give you a hint, okay?
Okay.
Negative 1 is the same as being left 1. And then if you go left 9, after you've gone left 1, where would you end up at?
Negative 10.
That's so good. That is so good.
How long is it?
Okay, then there's another way to do it, okay? You can put all the negatives on one side and all the positives on the other. So like I'd have 2, 4, then since it's negative 3 or subtract 3, same thing, you put those over here. Do you want to keep going with that?
Okay, and then 5 would be positive, right?
No, there's a rule. Subtract 5 is the same as negative 5. Subtract 3 is the same as negative 3.
Okay.
Or you can think all the addings on one side and all the subtractings on the other,
Okay.
for now.
5, 7.
And then 9 is plus.
Oh, I don't know why I did
Okay.
that.
That's okay, it's easy to go back and forth.
9.
Mm-hmm. Good. So
Let me move the screen up because you're going to have to add those numbers up now.
So the positive ones are like steps forward, and these are like steps backwards. So you can think, how many steps forward and how many steps backwards did I have? And I don't think I didn't write that very well. That's a 4. Okay. That's right. So we have 26 steps forward. 36 steps backwards. And to show that it's backwards, we put negative 36. So we can write that as 26 minus 36, or you could write negative 36 plus 26. But either way, you have 26 forward and 36 backward.
So the difference between those is 10, right? You see that the difference between 36 and 26 is 10?
Yeah.
And the larger number is 36, and it's negative, so that's why it's negative 10. All right, nicely done. We'll be back with more right after this.
David, Drive? Bulldogs. Good afternoon, Bulldogs. How are we doing today? Good. Good to hear. Now we're here today with all of our wonderful guests. We have board members, we have media, we have community members, we have people from Chevron as well.
There's a lot of talent right here in Kern County. The students are really smart. They want to learn. They're eager to learn more. We want them to become leaders in Kern County, and this is one way we do that is by partnering with Donors Choose and getting teachers really excited about enhancing the environment for kids.
A lot of the times when we have STEM education, we don't have the budget or we don't have the technology. Donors Choose and Chevron makes it possible for us to receive those tools that we need to teach. They get excited. They love being hands-on and using all this software, all this digital stuff. We're getting 30 drawing tablets to do graphic design. They learn to design a product from beginning to end, and not only that, they get to print it in a 3D printer. Now, with these donations from Chevron, we're going to be able to create the design part of it. They are going to design the packaging, the logos, and everything that goes with their products. So they're going from beginning to end with the design process.
What you're going to hear is you're going to hear the waves, but I'm going to hit the second resonator and you're going to hear a wah, wah, wah sound. Ready?
The STEM is just one area that we focus in, but today what you're seeing is students are learning hands-on in a number of projects.
We are actually introducing a lot of 21st century jobs, such as graphic design, industrial design, engineering, and it takes a lot of those skills for them to get a job in the 21st century that they're learning here.
All right, once again, we do have phone tutors available until 5:30 this afternoon. We have one more opportunity to head on out to the STEAM Academy at Castle Elementary with Tony.
All right, thanks, Mike. So we're back with some final tests.
Alright, so that was like more like the fastest balloon. Because that was 16 seconds. That was 16 seconds.
Can you help them, Dr. A? Just hold. Anybody need help holding?
That was 16 seconds.
Okay, ready?
Can you hold that?
They've got a
I'll
great
hold
idea.
that for
Okay,
you.
ready?
Yep.
One.
Here we go.
Uh-oh.
Oh!
Here, quick.
I
Hold
didn't
that.
go as
We're gonna
far.
try it.
We got this, we got this.
Hold on. Okay. Ah!
Okay.
It
What else
was
do we have?
because of the thing holder.
What else do we have? Are you ready?
Which one are we doing? That
Oh! All right, you guys ready? Okay, go across.
I don't know, now I'm kind of like, my little piece of little.
Okay,
you want to pull it? All you gotta do is unclip it. Okay, ready? Here you go. Nope. You know work.
Okay, so go back, talk about what worked in the other groups.
Okay,
Go for it.
So what worked for us was we didn't add anything to it, and that's because it didn't have pressure. And and last time it had way too much. It had way too much. So they didn't have a cup. I couldn't see there, so I can't.
These had the straw and the balloon.
Okay, and a little bit of tape. Really good.
only one balloon?
No, that's what I told. I said let's do that because for thing night last year, that's the only one we did, and it went pretty far.
They
So.
try. No, okay. They try your turn. Closing it way too tight and tying it to pencils, and that made it like stick. Hey, set. You guys have 4 minutes on the clock.
It was a good idea, but
Yeah.
it didn't really work out. First, we tried it with holes to see if like a little bit of the air could come out,
Okay.
but more.
And then it pushed.
But
And you were kind of using that like as a maybe a sail mechanism or
yeah,
something?
to where it
Okay.
would be like instead of just.
Okay.
But now it's a. So
That's okay.
we're trying.
So we noticed that may not have worked for, but it worked for, that's all right.
But,
Yeah.
Back to the drawing board.
Absolutely.
If you guys all get together, all of you
Okay.
talk about what you did and what they did and how you could improve each other's design.
So while they're working on that, we'll maybe showcase a couple other things that students do here at Castle and just the engineering lab. So we've got some designs here of earthquake-proof buildings. Students design structures, test them on a shake table, and then go back to the drawing board and study what engineers use in buildings to help them withstand the shaking of a violent earthquake. And then they redesign, rebuild, and test their buildings again. We've got over here a lot of 3D printed and designed hearts, and these are actually molds for bath bombs. And students not only design the mold, but they also discuss how many bath bombs they can make with a certain amount of ingredients and discuss even the chemistry behind some of that. So they design in Tinkercad, and then they 3D print here on one of our 4 3D printers. And let's see, they also work with, you can see in the corner there, they program and they code Vex Robotics. And we have an after-school class that's our robotics team that really just started this year and is getting going on learning how to build, design, code, and then complete one of the many games from the VEX competitions. In this challenge, one of the neat things that I heard a student say when we asked them, so what have you noticed so far about the designs and the outcome? And they said, it seems like maybe some of the more complex designs didn't do as well. And that's great. I would rather they come up with that on their own than go back to the drawing board, as opposed to me tell them, you know, that design is not going to work because of this. You know, I've seen it many times before and I can tell you, but I would rather they come to that conclusion. So once they do that and then redesign and test, then they can usually share between groups and discuss what works really well and justify their performance with, again, math and science. So that wraps us up here at Castle. Back to you, Mike.
Thanks for that, Tony. Thanks to Bree as well. Nice to see the kids working and modifying on their designs at the Castle STEAM Academy. We do have phone tutors available until 5:30, and we'd like to say thank you to Katelyn for coming in. And we're also going to be sending you to a Bakersfield Condors hockey game. Have you been to a Condors game yet?
No.
Well, this is going to be an opportunity for you, and I do believe they have won 15 games in a row. So that is something hopefully they can keep going as they head into the playoffs. And you know now that you have an official uniform, so turn this way, because you are now an ambassador for Do the Math. Do you have any idea what that means?
Yeah, it's big enough.
No.
No? Well, that means you're going to tell kids about Do the Math. Can you do that?
Yes.
All you have to do is when you're wearing the shirt, and you'll probably wear it every day from now on, but not every day, all right? And somebody's going to go, hey, what's going on with that? And you can say, hey, it's a TV show. They help you out with your math, and you can go on sometimes and work out some new math. You can do that?
Yeah.
All right, cool. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.